This is Jeremy Clark of JeremyBytes.com, and today we're going to do a quick overview of C# properties. The thing about properties is that they look like data. So here we have a property with a backing field where we have a private string first name and a public string first name with a getter and setter. And it looks pretty straightforward at first, but if you don't understand that these are really methods, then it gets a little confusing. Also, something that's very common is to see automatic properties that just have get semicolon set semicolon. And this gets even weirder if you don't understand what's actually going on under the covers. So let's just take a quick look at what properties are, how they behave, and we're going to dig into a little bit of the IL as well so that we can take a look at that. So here we are in Visual Studio, and you can see here that I just have a public class called person. And let's go ahead and add a property. Now, I like to use snippets wherever possible. It's one of the cool things in Visual Studio. So I want a property with a backing field. So I'm going to type in prop full, and you can see that I get a code snippet for property and backing field. If I hit tab here, then it will give me a chance to type in the type. We'll go ahead and make this a string. If I tab again, I get the name of the backing field, and we'll go ahead and say first name. And if I tab again, I get the name of the property. So you can see this makes it very, very easy. When I'm done, I just hit enter, and there's my property with the backing field. And again, here we have a getter and a setter, and all the getter is doing is it's returning the value of our backing field, which is lowercase first name. And then in the setter, we're just assigning whatever value we're given to that backing field. Now this does look a little strange, but if you come from another language, it actually makes a lot more sense. If you're in the Java world, they don't have property syntax that looks like this. And so here's how you would normally see a property. Let's go ahead and create a phone number property. So I would have a private string for phone number, and that would hold my actual data. And then I would have a pair of methods to access this. So first I would have a getter. And so this would return a string. So we'll say public string get phone number. And this would just return the value of the backing field. And then we would also have a setter to go along with this that will set the value. Let's call it set phone number. And this will take a parameter that we'll just call value for consistency. We'll see why in just a moment. And here we just set that backing field to the value just like that. So this makes a lot more sense when you look at it as the private string phone number. That's our data. That's something that our class actually owns. We don't want to directly expose that to the outside world, so we encapsulate it in a pair of methods. We control access to it. This way, no one can update that value without our class knowing about it. And that's really the key here. Now, where this gets kind of interesting is when we start looking at the IL, the intermediate language that actually gets compiled from this. Let me go ahead and build this so that we have a DLL we can look at. And notice I'm in release mode here. I'm going to go up to my tools menu, and I'm going to pull up ILDASM. If you want some more information on how to set up ILDASM as a tool, I've actually got a blog article. You'll see the links for this particular video. When you have it set up like this, and I just say tools ILDASM, it will open up the DLL that I currently have in Visual Studio. So here we can see the person library, and here's my person class, and you can see we have a number of objects. Let's go ahead and zoom in on these guys a little bit. So you can see our two backing fields, the lowercase first name and lowercase phone number with those teal diamonds next to them. That's not really a surprise because those are the private fields we created. Way down at the bottom with the red triangle, you can see there's our first name property. We'll look at the insides of that in just a moment. But then look at our methods. So those purple squares, those are our methods. We have get underscore phone number and set underscore phone number. Those aren't very surprising because we actually created those methods. But what about get underscore first name and set underscore first name? We didn't create those. Well, it turns out the compiler does that for us. So let's take a look at how this actually gets wired together. I'm going to go ahead and double click on our first name property. So if someone does a get on the property, that .get, then what we'll do is call the get underscore first name method. We'll actually execute that method. If somebody tries to set the property, the dot set, then we're actually going to run the set underscore first name method. So this is how our property actually gets wired up to those methods. Now let's compare the getter for the first name and the phone number. So let's go ahead and just open up both of these. And let's get them in a spot where we can kind of look at what's in each of these windows. Now what I want to show is that these are basically exactly the same. Let's look at the body of the IL first. So if you see that first line, the IL underscore 0000, that has LDArg.0. That's actually load argument. And this happens at the beginning of every instance method. This is probably more information than you really need about IL. But in an instance method, you need to have a reference to this, the actual object you're calling it on. And so every time you open up the IL for an instance method, you'll see that load arg0 there. And that just pushes this onto the stack so that it can be used by the rest of the method. Now notice the next line we have LDFLD, that's load field. And notice that we're loading the first name field or the phone number field, whichever one is appropriate to this particular getter, and that actually puts it onto the stack as well. So that'll push the first name onto the stack or the phone number onto the stack. And then finally we have the ret, that's return. And so that'll return the item that's at the top of the stack, which will be the value of the first name or the value of the phone number, depending on which method we're in. If we look at the methods themselves, the definitions up at the top, we'll see that they are almost the same. One thing to note in get underscore first name, it has an extra identifier up here called special name. Now what that means is that this is something that the compiler generated, and we're not allowed to call this method directly in our user code. So if I tried to say person.get underscore first name, it would just result in a compiler error because this special name is basically saying, don't let anyone else call this. This is something that we generated and we don't want anyone else to touch it. So what we can see is this standard property with a backing field behaves exactly the same as if we had created our own pair of get and set methods. So properties are really methods rather than data. It's a way of encapsulating our data so that we have that hidden data in the background and we control access to it. So if we wanted to create a read-only property, we just don't put in a setter, or we make the setter private if we want to use it internally. And if someone wants to go ahead and get the value and we want to do something special with that, our class has full control over it. And that's really what properties are all about. Okay, so now that we've looked at full properties with backing fields, let's go ahead and take a look at the automatic property syntax. Now, if you want to use the snippets, it's pretty easy. We just say prop, and that will give us an automatic property. If I go ahead and hit tab twice, you'll see we get a similar template here. So I can say string, hit tab, and we'll call this last name, and I'll hit enter for that. Now notice it just has an empty get and set block. If we don't need to do anything special, this is all we need to do. So let's go ahead and build this and look at the IL that's created now. So again, we'll go ahead and open up IL-DASM. And if we open up our person class, we'll go ahead and zoom in. So you'll see that we see some items that we expect and something that looks really, really strange. Let's take a look at our backing fields. Again, those are the teal diamonds here. We have the first name field and the phone number field that we had before. But then we have this thing and it's got angle brackets and it says last name K double underscore backing field. What this is, it's a backing field the compiler generated for us. So that automatic property, it's a syntax shortcut so that we don't have to type this all out into our code, but it actually gets compiled exactly the same way as if we created a backing field. So it creates it with this name that's kind of weird, and that'll just make sure that it doesn't have any kind of name conflicts with anything we might generate ourselves or with something else that's generated by the system. And then you'll see we have our methods, and you see we have our 3 getters and our 3 setters like we would expect, and then our 2 properties down at the bottom. So first, let's go ahead and just compare some backing fields. So here's the first name backing field. This is the one that we created ourselves. And then here is the backing field for the last name property, which is what the compiler generated for us. So you can see for the top one here, we have dot field private string first name. Pretty simple. And actually for the backing field for the last name, that first line is exactly the same. Dot field private string and then the name. Again, the name is a little strange to prevent name conflicts. And then in the second line, we actually have a note here that this is compiler generated. Notice the use of compiler generated attribute here. So this is something that lets the IL know that this wasn't user generated, this is compiler generated. Let's go ahead and compare the getters for the first name and the last name. And again, what we'll see is that these are almost identical. When we look at the method definition, we have all of the same identifiers that we had before. So method, public, hide by sig, special name, instance, string. I'm not going to explain what all of those are. If you're interested in IL, you can go and dig into them. And then notice down in the last name getter that we have that compiler generated attribute again up at the top of our method. But then the rest of the method body is exactly the same. So we have that load arg0, which again puts this onto the stack. Then we have load field to either put first name or that last name backing field onto the stack. And then we have return, which will return the value of the appropriate field. So the compiler generates exactly the same IL code in either case. The only difference is, again, we have this compiler generated attribute that just notes that, hey, this isn't something the user built, this is something that the compiler built itself. So the question is, now that we have this automatic property syntax and we see that it generates exactly the same code as if we have the backing field, why would we ever want to create our own properties that have backing fields? The answer to that is sometimes we want to do additional work in either the getter or the setter, so we need more control over it. So for example, if you're doing dependency injection with property injection, something that's very common to do in that case is to have something in the getter that checks to see if the backing field is null. And if it's null, we'll go ahead and new up the right object for it and actually return that. Otherwise, if it's not null, we'll just give you whatever's in the backing field. For the setter, we can do a couple different things. Maybe we want some validation code, so if someone tries to pass a blank value in, we just ignore it. Or if someone tries to pass in a value that's out of range, we throw an exception. We can also put security code in there to say whether or not, have some checks in there to see whether or not you're allowed to change that value and act appropriately. And then something that's very, very common, if you're in the WinForms or XAML world, you might be using the iNotify property changed interface. In that case, you have something in the setter that raises an event so that the UI knows that the data has changed on the backing field. And that way it can rebind the UI controls and make sure that the latest data is what's showing up in the user interface. So that's it for our overview of C# properties. If you want more information, be sure to visit www.JeremyBytes.com.